Okay, hello. Good afternoon. Thank you for joining me at 3:30 on a Thursday afternoon to talk about the AWS Nitro system. My name's Matt Eglin. I'm a solutions architect at AWS, based here in Brussels. Don't let the accent fool you. I am British by origin, but I do live here now in Belgium. I do like Belgium. Lovely place to be. But today, we want to talk about AWS and Nitro. We'll go through a few things. We'll start with what is the Nitro system, a great place to start. We will talk about its design and implementation. How did we actually get to the solution that we have? We will talk about the practical applications, how it protects you and your data. And then we'll also talk about something called Nitro enclaves, which is if we want even more protection and isolation for our workloads on AWS. To start, what is confidential computing? We want to talk about confidential computing, but let's be clear on a definition of confidential computing. I'm not going to read it out, but I think a key point that I want to make from this is it's for the protection of your code and your data while in use. And that protection is not necessarily just from bad actors, maybe in your organization, other customers in our infrastructure, but also ourselves as the service provider. Because we want to have protection on all of the different sides so that you have assurance that what you are using within AWS is indeed private and isolated to you. And hopefully, while we go through this presentation, you will see how we do that and how we've put in, I will say, quite a bit of effort into designing our hardware and software to go together to provide that to you. A bit of background on Nitro. So we've been doing this since 2017. It officially launched in November 2017. All new instances on AWS are using this since 2018. Okay, so you may not have noticed it, but if you have launched an EC2 instance, I will ask an audience show of hands. Who's launched an EC2 instance since 2018? Okay, so everyone, you're all using Nitro without realizing it. You're using the underlying infrastructure. Nitro was built because we found that the existing hypervisors, the existing hardware wasn't cutting it for us. We've been developing this since 2012. And since then, we've re-architected the way we use our hypervisor and the way in which we use hardware within our infrastructure to provide performance, but also a high level of security to both our customers and indeed to ourselves as a service provider. There have been 5 generations of custom chips. We'll actually look at them in a little bit of detail. And you will probably guess from the fact that there's 5 generations is that we are constantly evolving this solution. We haven't stopped. We are continuously increasing what we do with Nitro, the performance, the speed, and what it can achieve for your workloads. But we'll step back to 2017, 2016. This is the legacy. This is what we had before Nitro. We had a very traditional Xen hypervisor. We had different components that were interfacing with what we call the DOM0, which was a Linux virtual machine, hardened Linux virtual machine, but was providing our interactions with our networking, our storage, underlying instance data stores, and indeed the management and security of the system. This is the old way of doing it. But we quickly realized that there's a lot going on here. There's also a lot of processing that is occurring on the device that we don't need. We've got our customer instances. We want to give as much space to those. We want to give those maximum performance. And we also realized that there was limitations to using some of the off-the-shelf components and off-the-shelf software to run the hypervisor. So what did we do? In Nitro, we started splitting things out. So the first thing that we split out was the VPC control, the virtual private cloud. So the communication from any instance into the virtual private cloud. We split this out into dedicated hardware. So the hardware itself is now responsible for communicating out from the virtual machines. And this is no longer handled by the internal Linux machine you see here as DOM0, or indeed the hypervisor. So we started moving components out of the instance. And this is into separate hardware. We secondly moved out the elastic block storage, so block storage control, moved again to an external service and an external card. So we're slowly moving the components of our hypervisor, of our virtualization solution, outside of the instance, the main instance that we're using to run customer EC2 instances. This continued. We moved out local storage and the management and security And ultimately, we also removed the DOM0 machine. We didn't need it anymore. Why are we running a virtual machine within our infrastructure provision? In order to provide management and control and coordination. We don't need it. What we do have now, or instead, is we have a Nitro hypervisor. This replaced the Zen hypervisor. And this is custom built by AWS. And this provides the coordination and control between the customer instances and indeed the components that we see on the left within the Nitro system. So we've really slimmed down the provision of what we have here. So this gives us more capacity on the host. So the physical machine itself has more capacity. But as you will see further along in this presentation, by splitting off these different components into discrete hardware resources, it enables us to do some quite interesting things with things like encryption, performance, and protection of the instances themselves. So I mentioned that we split off into different cards. So there's 4 main cards, well, 5 main cards within Nitro. And they're doing different discrete things. Now, why are we splitting these into separate hardware? Well, it's a performance issue as a start. Within these different cards, we can provide the I/O performance. We can provide encryption, hardware-based encryption, for data that is transiting from the instances to elsewhere within the network. And by not doing this on the instances themselves, there's no impact to the OS, and there's minimal impact to the actual hardware that's providing the hosting environment to the virtual machines. We also have the specialized Nitro security chip. We'll talk a little bit more about that later. However, this provides a root of trust to what we are executing within these environments. And this is a key component of our Nitro infrastructure. And the Nitro hypervisor as well. This is lightweight. Minimal code, minimal execution. We want it to do as little as possible. And why is that important from a security perspective? Is because if we don't need it, we can throw it away. We're giving ourselves minimal vectors possible within the infrastructure for things to occur. And you'll see exactly what we've ripped out in a little bit. And it's also worth noting, it's bare metal-like performance. So performance is key. The less we have in the hypervisor, the closer we can get to the infrastructure, the bare metal of the machine, the more performance we can get out of each box. And to give you a visual representation, these are the Nitro cards. I don't know if these are the latest issues of the Nitro cards. We keep issuing new ones. But the Nitro cards, as you can see, specialized hardware. They are made by Annapurna Labs, which is a company we purchased, I think it was back in 2012 or 2015. And with Annapurna Labs, the silicon is being designed to be custom made for the different tasks that these cards are executing, whether it be communication with block storage, with the storage services, whether it be communication from a network perspective, or indeed communication into the instance metadata stores themselves. And we started with Nitro 1. Now if you've used AWS before, you may have heard of our Graviton processors. These are not Graviton processors. This is the custom Nitro silicon that sits on those cards that you just saw. So we've been going in multiple generations. We've got 1, 2, 3, 4. Now on version 5. We continue to innovate. So we now have 2 times more transistors. It's faster from a memory access perspective, and there's more bandwidth. Why do you care about that? It means that the actions you are undertaking within your virtual machines, and indeed within the services that you use on AWS, will be faster. So if you have instances that can do faster network, faster access to block storage, especially these days when we're looking at accessing things like large data sets for generative AI and machine learning, we need that to be quick. And using the specialized hardware, we allow for that communication to occur at these rates through from the virtual machines that you are executing through to the storage that you have within AWS. So we're continuously trying to make that faster to support those workloads. The Nitro cards we said here, we'll talk about 4 main ones. I mentioned them before. Data plane control. So this is when we're talking from the virtual machine out to the network. The NVMe PCIe controller. This is talking to any block storage that you have associated with the device itself, or virtual machine, I should say. The NVMe PCI controller for the instance store. This is specifically designed to talk to any storage we have on the box itself, on the physical hardware, which is different to any storage you may associate with the virtual machine in your virtual private cloud. So we actually split those 2 out, so we have different ways of encrypting those data, encrypting that communication. And importantly, finally, we have the system control card. Now, this is where, in my opinion, it gets quite interesting, because this is how we actually control Nitro. This is how we actually have a level of governance and control to the instances that you're running within AWS. What this provides, very importantly, is a passive API endpoint. So this allows for actions to be undertaken on the machine itself. So this could be start, stop, terminate an instance. But this is a completely passive solution. So we're indicating to the Nitro controller what it needs to execute upon the hardware. There's no active API here, so we can't actively access this. We must just send the request directly, and it coordinates all the other Nitro components within the system. So it's a very, very, very important card. What this means is that there's no direct link between the EC2 instances and the control plane from within AWS. So for example, if you're in the console, you want to start an instance, this represents an API command that gets sent through our infrastructure, which is then signaling the Nitro cards that it must start an instance upon that machine. There's no direct communication that happens between the control plane into the virtual machine itself, or indeed into the instance. We must signal this within Nitro. Nitro then takes over within the machine. There is no communication into the machine itself. So we're cutting off that communication. So we're providing that isolation between us as the service provider and where your instances are executing within the Nitro hardware. We authenticate and authorize every API call. This is using IAM. So every call that is made is authenticated and authorized. And one of the very interesting things, we formally verified this process so that we are confident that there will be no memory or network faults when we trigger this process. This is critically important because we are only ever triggering and asking almost the Nitro system to do things. We have no way of debugging that because we have no access inside the machine. If something went wrong and we hadn't formally verified that we knew exactly all the inputs and the outputs, we could have a state where the machine stopped working. But we formally verified all the inputs, the outputs, and the data flow to ensure that this would not happen. It's one of the things we had to do to ensure that we could provide that level of isolation. One of the advantages that Nitro provides also is transparent hardware encryption. I mentioned we have separate cards for communicating out to the network, to communicating to storage. Each of these cards provides hardware accelerated encryption. So when we're communicating to our storage, when we're communicating across the network, we are encrypting both by default within AWS. But for example, if you've encrypted your storage, the hardware itself is being leveraged to ensure that there is zero performance impact on the data communication between your instance and the storage. It's also one thing I must mention is that this is non-blocking. So the I/O that is occurring is not being blocked in any possible way. It's a non-blocking communication between the instance and the data store itself. So we worked very hard to make sure that that was possible. And very importantly, the encryption keys, as it says here, they're only ever in plain text within the protected memory of the card itself. So when you're communicating with encrypted data stores, for example, in Elastic Block Storage, the encryption key that's being used to decrypt that data never is made available to the virtual machine at an OS level. So in the event of anything occurring, there's no chance of that key being lost. The key never leaves the Nitro card itself. So we protect it in this way. Depending on how you're doing it, we have some different ways of doing key management. With the Elastic Block Storage, now, for those who do not know, Elastic Block Storage can move between different virtual machines. You can move your storage to a different virtual machine. So we can't keep the key associated with the virtual machine itself, because that machine may disappear. We may want to spin up a new one. Within EBS, we have the Amazon KMS, the key management system, that manages the issuance of these keys. And we ensure, therefore, that keys can be permissioned and authenticated, and you can access the different block storage devices between different virtual machines should you need to move that around. But again, the keys are protected within Nitro. Instant storage, that's any storage that's on the box itself. They never leave the box. Within that controller card that I mentioned that connects to the instance storage, keys are generated, used, and destroyed whenever you have an instance on that box. They never leave the box itself. So we protect those there. And with a VPC perspective, because we have data that's transiting across a network potentially, you may have different services that are in use. Again, the keys are protected within the Nitro controller cards and protected memory. However, so that we can actually have some level of keys being able to be reused in different locations, we have seed material that is centrally generated and centrally distributed to the different regions and the different availability zones from which keys can be derived. So therefore, we have an ability to have keys that are A, rotated, and B, that can be shared between different instances, depending on the services that you are using. And as I mentioned, the Nitro hypervisor is a bare minimum. It's only ever executing on behalf of the requests that are made to it. It is what we say quiescent, which is a word I did have to look up. It is quiet. It is minimally chatty. It only does things when it needs to. And we found this to be minimal and performant. And when I say minimal, this is the bit that surprised me and surprised people. What we don't have within the hypervisor is all of the above. An important one is we don't have any SSH server. There's no shell. There's no networking stack. That's all been offloaded to the Nitro cards. This means that this is also why we took a lot of effort to formally prove the process. If something was to go wrong within the box, we are providing the service. We have no way of getting into this. There's no way, we can't SSH it, there's no access. We can't get into it. You'd have to pull it off the rack and somehow figure out what went wrong. But this is why we put in so much effort to ensure that when we're signaling the box to do things, it does exactly what we expect, or at least ends to a state where we can signal it again to continue. As I say, the primary functions, it's that command control from the Nitro hypervisor. It partitions the memory and CPU between the virtual machines that are executing. Now, this is very, very important because we don't want overlap between memory and CPUs when you have different virtual machines operating on the same hardware. This is actually became extremely interesting with some when there were some vulnerabilities in processors a few years ago. But within the Nitro hypervisor, there is no sharing between virtual cores and processor memory between virtual machines. That is handled by the hypervisor, and there is a hard gap between each virtual machine that's operating on the same hardware. So you can't jump between different memory. It cannot be addressed. And with a Nitro security chip, so this is another key component. This sits on the motherboard itself, on the main board. It seeks to trap all I/O between the host machine itself and any non-volatile storage on the box. So when I say non-volatile storage, I'm talking about anything that's sitting on those Nitro cards, any firmware that's on the hardware that we have within the server. And it's also being used to validate and verify the software that's on the firmware, that we have executing on the device. Why is this important, though? Because we have virtual machines, right? The virtual machines should never be able to access the hardware. But you can do that. We have what we call metal instances. So you can operate on the bare metal. So if you have an instance that is metal, the hypervisor doesn't exist. We take the hypervisor away. You have access to the machine. You have all the cores, all the memory, all the hardware that's available to you. But, of course, we want to ensure that that machine is still protected from any nefarious activities that may take place. So we block that write. So we intercept all writes that are possibly going out to non-volatile memory using this chip. The firmware is also, I think this is quite cool, injected every time the machine boots. So every time, I should say we block all writes, every time the machine boots, we inject new firmware into the device. So we always start with a new, clean set of firmware on the device itself. So we leave nothing to chance. I mentioned before, we protect the virtual machines that are executing within the hardware. There's no memory page coalescing that occurs between the virtual machines that are active. There's no simultaneous sharing of threads on the architecture. The cores and the memory are pinned, as I say. And that keeps that level of protection. We were talking about protection from us as the service provider, but this is where we're now separating the virtual machines from each other and preventing any compromises that may occur from jumping into different blocks of memory or into different threads that are executing on the same hardware. So there's a hard barrier between. Caveat is burstable instances. So if you're using burstable instances, they're operating periodically on spare capacity that exists within EC2. However, we have considered this, and we do prevent the threads coalescing, and we do prevent memory being coalesced as well with burstable instances. So we do ensure that the instances are queued and moved away as they execute. But it is slightly different. This happens in software. Just a nice picture of the EC2 server, so you can see what it actually looks like. If we ever take one out of a rack and we take the lid off, very, very clean bit of design. You can see there's a lot of cooling in there, of course, but you can see the large amount of cards that are sticking out the front, and these are the Nitro cards that are providing that control and that I/O, the encryption, as I say, that's occurring on the cards, and also the control of the device itself. And I had to reiterate here, of course, that there's no break glass. If there's no way of us getting into those machines, we don't have a break glass or like a backdoor or an emergency key we can pull. If something goes wrong, we have to pull it off the rack, replace it with a new one. Hopefully that works and starts. Then we have to figure out what went wrong. Hopefully it's not failed hardware. If you don't take our word for it, NCC Group made a third-party affirmation of what we say about Nitro back in 2023, excuse me, where they spoke with our engineers. They looked at the code that underpins this in the hypervisor, and they attested that, yes, indeed, from what you're saying and what we see, we think these claims are valid. So the report is freely available on our website. Please go read it. There's also, I haven't got a slide for it, but there's also a fascinating white paper called The Security Design of the AWS Nitro System that really goes into the weeds. I think it's about 45 pages long. Super interesting. Really goes into how we design this as well. As we sort of come to the end of this presentation, there is something I need to mention. So Nitro exists, and everybody who is using EC2, everyone who is using AWS services is taking advantage of this protection. But sometimes the protection is not enough. So what do we want to do if we have, because we talked about protection from us as a cloud service provider, protection from other users of the same machine within virtual machines. What if you want to protect it from yourself or someone else in your business? That's the third option. And this is why we have something called an AWS Nitro Enclaves, which is an ability to start a virtual machine which has no access even from those who own it yourselves, where it can execute a singular task and then exit. I'll show you what that means. We have customers who are handling very sensitive data. This could be healthcare data, intellectual property, trade secrets, information that you may not even want to share internally in your business and might be under heavy protection. You don't want to make it available on a file share, on an S3 service. You want to ensure that this is only used for a very specific action, but you don't want the danger of potentially someone being able to read it or access it. What we have is the ability to spin up an instance called a Nitro Enclave, which holds a secure channel with what we would call a controlling EC2 instance. And this is the only way that we can actually communicate to this new instance. Now, this instance can be used to provide processing of data. It can be granted encryption key access. It can be granted access to data stores in your environment. And again, as I say, it's isolated from all other devices, all other virtual machines, and also not accessible by you as the user. Where this becomes very, very useful is if you especially have multi-party collaboration. If you need some data from party A with some data from party B, and maybe party C and D, but you should never be able to see this data. You need to have the output of this processing, but you don't want that data to be made available. You don't want it to accidentally fall into the wrong hands. You can do this with the enclaves because the enclaves can spin up, they execute a singular task, They take the data. They do. It's all completely. What's the word am I looking for? You can't see what's going on. You can't access it, but you can, for example, send the response. Actually, it's in the previous slide. The response back to this EC2 instance on the other side. So you can get a result, but you don't see any of the processing. You don't see any of the raw data that made that result. So especially useful for very sensitive data sets. And just to give you exactly to how this looks, this is the typical way we have our instances. Nitro hypervisor on the host, instance A, instance B, with an enclave that sits as a completely isolated instance again. Has that secure local channel that allows for a limited set of communication between the controlling instance and the enclave. It can do what it needs to do. It can process that data. It can send the result back to instance A here, and then it can terminate. And at no point did we make data or sensitive information available outside of that box. It is a little bit more complicated to set up. So the standard Nitro way of doing things may be sufficient for your needs, but if you need a little bit more, Nitro enclaves do exist. Just to conclude, as I say, every instance since 2017 has used the Nitro infrastructure. So you already are using it. It's the foundational pillar for security and confidentiality within AWS. We treat it very seriously. As I say, we provide protection from ourselves as the provider, from other users of the service, and indeed, if you need to, from others in your own organization as well. So making sure we have that privacy and protection. The software and hardware is built together. We build it, we own it, we make it. And I should say Annapurna Labs, as I said, we purchased them, so they're now part of the Amazon family. And Nitro enclaves exist for when you need that further isolation. But, as I say, the Nitro system may be sufficient for your needs in terms of providing that segregation and protection that you require. Thank you very much. Thank you for listening. If you feel so, I have a little survey here. I always like to hear about what you thought about the presentation. Feedback is encouraged and welcomed. And if you'd like to chat more, I'll be standing here. Thank you for listening.